Hello everyone. Today in this video clip, I'm going to cover section 9.2 in our pre-calculus algebra class. It's about the arithmetic sequence and partial sum. So first, let's recall the definition of the arithmetic sequence. Last time in the previous section, I mentioned briefly about the arithmetic sequence. So basically, you have a sequence where the preceding term, the next term, is calculated by having the previous term and add to a constant. So what you're going to have is two things. Given the first term, let's call A1, and a number D, okay? Then the arithmetic sequence will define this way, recursively. AN, the n term in general, is equal to AN minus 1 plus D. So what we're saying in here is what? You have the very first term, okay? And you have D here set for the common difference, D, a constant, a number. And then start from the first term, you can calculate second term. A2 is equal to A1 plus D. And then A3 is equal to A2 plus D. A4 is equal to A3 plus D, so forth and so on. Now you have every term. And this is the definition of the arithmetic sequence, defined recursively. So the main tasks we try to work on arithmetic sequence is, what is the general formula? What is the general formula for the n term? Okay? How do we find the n term directly? And then we move on to the partial sum. So let me give you how we calculate the n term in general. So we have A1, it's just A1, okay? And how do we calculate A2? Is A1 plus a constant D, right? Let me give you an example at the same time with the formula. Say I got this sequence, 2, 5, 8, 11, 14, 17, 20, So the first term here is A1 is equal to 2, okay? A1 is 2. And how do we get to the second term? 5. We add 3 into it. We got 5. So A1 is 2. And D is equal to 3, right? A1 equal to 2. And D is equal to 3. From 5, you add 3, you got 8. From 8, you add 3, you got 11. From 11, you add 3 into it, you got 14. So forth and so on. So we start with the first term, just A1 in general, right? In this particular example, it's 2, but anything. 2. And then from the first term, you add D into it, you have the second term. Similarly, you have the second term already, you can calculate the third term is A2 plus D, right? But we know A2. A2 is what? A1 plus D. So this is no more than A1 plus D. I think I should write it down here, it's easier for you guys to see. The A2 is A1 plus D, and then plus another D. This could be A2 plus A1 plus 2D, I mean. Alright, after having A3, now we can calculate A4 is A3 plus D by definition. Calculate A4, you use the previous sum, which is A3 and then plus a common different D. And you know A3 already. A3 is A1 plus 2D, and now add another D, and simplify, combine the like terms, you got A1 plus 3D. Okay? Try one more. A5 is A4 plus D, right? And you know that A4 is A3 plus, was that right? A4 plus D, yeah. A4 is A1, plus 3D. And then plus another D. It's gonna be A1 plus 4D. Now, with the first couple terms, we try to figure out the pattern a bit, right? A1 is just A1. A2 is A1 plus 1D. A3 is A1 plus 2D. A4 is A1 plus 3D. And A5 is A1 plus 4D. And repeat the same way, you can see that A6 is going to be A1 plus 5D. A7 is A1 plus 6D. So forth and so on. So with that rule, you can see what? say A100 is going to be A1 plus 9090. Okay, so the number of D is going to be 1 less than the position of that number. So we can figure out the general formula. AN is going to be A1 plus N minus 1 D. Okay, and this is not the formal proof yet, but show you the steps as we try to figure out a general formula, and actually we can prove it using something called a mathematical induction, which we're going to learn in section, I think 9.4. But for now, get the formula. I'll just show you how we derive the formula step by step. Okay, so we have the general formula. So in here, A1 is 2, A2 is 5, and A3 is 8, A4 is 11, so forth and so on. You don't have to do step to step to calculate, say, A50. We don't have to do A1 all the way to A49 to get to A50. We can have the formula is what? A1 plus 4090, which is 2 plus 49 times 3. So this is 50 times 3 is 100, and 50 is 149. Okay. All right, and of course you can calculate any term you like if you have the general formula. And this is the first part of our section today. We calculate the n term in general without depending on the previous term. It's called a general formula. And by the way, the formula right here called the recursive formula. We use this our definition. Okay, this is a more powerful formula, helping to calculate any term using just two things: the first term, which is given, and the common different D's, which is given as well. And the n term really depends on just the first term and the common different D. You got every single term. All right. And after having the sequence, the next step would be about the series. And recall what we talked about series previously. Series is the sum of all the terms on the sequence. And if the sum add up being a finite number, we can say that the series is convergent. Otherwise, it means the sum is going to infinity, or the sum is undefined. Then we say that the series is divergent. Okay, and I claim that except for the zero sequence, this one, the zero sequence, 0, 0, 0, 0, da 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 forever, which is an arithmetic sequence will have a convergent series. You add all the zeros, you have 0. Other than that, all the arithmetic sequence will be giving you a divergent series, because if you have D that's different than 0, or A1 different than 0, when you then you have a non-zero term for n, and you add all the terms together, you're going to give you a sum that's getting bigger and bigger, or getting smaller and smaller. So the sum will always go to either positive or negative infinity. All right. So we will not be talking about the series. We can only talk about partial sum. And what is partial sum? We just add a finite number of terms of the sequence, not like forever. Okay. So let's talk about the second item, partial sum. Number 2, partial sum. Okay. And say partial sum denoted by S for sum. Okay, so Sn means what? The sum of the first n terms. Okay, so you have a series, say a sequence A1, A2, A3, A4. Then Sn means A1 plus A2 plus A3 plus da 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 all the way to An. Okay. So make sure that everyone get it. Say S3. What does it mean by this? This is the sum of the first 3 terms, and this means A1 plus A2 plus A3. Okay? What about S5? It means A1 plus A2 plus A3 plus A4 plus A5, etc. Right? Of course, S1 means what? A1, one term, right? S2 is A1 plus A2, so forth and so on. Okay? And we have the summation notation, the sigma notation for this. if you still remember from last time, is instead of writing it all out, we can write it this way. We call the sigma notation of AI, where I run from 1 to n, and that notation really means this A1 plus A2, A3, A4, all the way to AN. Okay? Question is, is there any way we can find the general formula for Sn? And the answer is yes. We do have a general formula. Okay. And let me write out a formula before I can explain to you. Sn can be calculated this way. A1 plus An, everything, times n divided by 2. Okay, box that for me. Now let me explain to you how we get there. I think the grade should be given to Gauss back when he was in I think middle school. We had something like this. Calculate the sum. 1 plus 2 plus 3 plus all the way to 100. How can we calculate the sum? It's called S, okay? The sum. So what did he do? He write another S in the backward order. So 100 plus 99 plus 98 plus all the way to 1. And we add the two sums together. So twice of the sum is what? 101 plus 101 plus 101 plus 101. So all of those terms are 101. And how many terms do we have? 1, 2, 3, all the way to 100 terms. So twice of the sum is going to be 101 times 100. Okay? Of course, sum is divided by 2 because this is twice of the sum. Okay? And we have the answer for the sum of the first 100 is a natural number from 1 to 100. Okay? We got the same idea in here to calculate the sum of the first n term in general for arithmetic sequence. So we have Sn is what? A1 plus A2 plus A3 plus data all the way to A1, I'm sorry, An in general. Okay? We say n equal to 100. Anything. Okay? And now I'm going to do the same thing, write out the sum Sn now in backward order. An plus An minus 1, A sub n minus 2 plus data all the way to A1. And we're going to add the two sums together. So twice of the sum Sn is going to be A1 plus An. This is A2 plus An minus 1 plus A3 plus An minus 2 plus dot all the way to the last one going to be An plus An A1. And I claim that all of those sum two terms in parentheses actually equal to each other. See, this is A1 An, right? And now you change from A1 to A2, you increase the D common difference by 1. And then what? An minus 1, you decrease D by 1 because An minus 1 is D less than An, and A2 is D more than A1. So D more plus D less is going to be the same. So all the sum actually equal to A1 plus An. Question is how many pairs of numbers you have in here? N of those. This is really N times A1 plus An, and all you have to do is divide both sides by 2. You have the sum. Okay? And now let's just go back to another example. This one. Okay. You have a formula. Let's go back to our very first example. A1 equal to 2 and D is equal to 3. So you got what? 2, and then 2 plus 3 is 5, and then 5 plus 3 is 8, plus 3 is 11, it's 14, 17, da da da. And we have a general formula. An was 2 plus n minus 1 times D, right? N minus 1 times 3. Of course, you can factor out, simplify if you like, because the formula was what? An is equal to A1 plus n minus 1 times D. That's what it is. All right. And now, what if people ask you to find what is S30? S30 means the sum of the first 30 terms. And this again means what? A1 plus A2 plus A3 plus all the way to A30. And according to our formula, it's going to be what? N times A1. By the way, N here is 30 already. N is 30. A1 plus A30 all over 2. We know A1, which is 2. We know 30, we know 2. But we don't know A30, so we can calculate it. A30 is A1 plus 2090, which is 2 plus 29 times 3. Okay? 29 times 3 is plus 2. This is like 30 times 30 is 90. Is 1 less. It's going to be 90. 1 less is 89. But this is 89. Alright, so we can plug in and calculate the sum. S30 is equal to 30 times 2 plus 89 over 2. Okay, 2 plus 89 is 91. 91 times 15 is 5. 45 is 91 in here, so 5, 6. Equal to 1365. Alright, and this is all about the arithmetic sequence and the partial sum. And by the way, I don't talk about series. You see why you keep adding up what happened? 2 plus 5 plus 8 plus 11. You keep adding bigger numbers. Then what? The total, the sum. For the entire, for all the terms, going to be infinity. Okay, getting bigger. And similarly, what if I got b equals, say, negative 3? Then what? 2 and minus 3 going to be negative 1, negative 4. The number getting smaller and smaller. You add them all, you're going to get a very negative numbers, negative infinity. Okay? So we don't have the infinite sum, but partial sum is okay. And this is the formula for partial sum. Oh, put it right, right here. S30, Sn is what? N times A1 plus An over 2. Okay? And this is the example. And I glimpse all the exercises in this section, 9.2, that you're going to see in your homework quiz and the exam. We'll go around everything that I covered in here. Thank you for watching, guys. Hopefully this helped. Again, if you have any questions, please don't hesitate to ask. Have a good day.